Say I want to buy a camera. What is the feature that I am going to look for in it? Price factors are separate. There are some device specific characteristics which I look for. If I am okay with that, or if I could afford that, or if that specifications will meet my needs, then I am just going to buy that device. So these characteristics are called as static characteristics of a device. How good is the device? How reliable it is? If a device is giving you certain output, how much you can trust them? In case if you can't trust them on certain scenarios, what are those and how to correct them? All these can be understood in static characteristics. We are going to talk about this in this class. Let's get started. If we are measuring anything, how do we believe in the reading that we get? Say we are measuring the temperature. The temperature is 36.5 degrees Celsius. So, how do you rely on the device? You are going to buy a standard and a certified product only, but still, if you want to decide whether the device is worn out or it is not functioning well, how do you check? You check the temperature by another method or by using another device. You assume that to be standard and you compare your test device against it. If your thermometer says your temperature as 35.6 degrees Celsius, you will check in the same standard device. You will measure the temperature using the standard device and check whether it reads the same or not. And whenever you are deciding on a standard, you need to be sure if the device is not faulty and the device is giving you the correct reading at all times. Only then you can take that as a standard and compare that with all the test inputs that you have, and you can come to a conclusion whether your device is working fine or not. So, in order for me to verify if my device is giving the correct output, I will be verifying it against one particular reference device. That is called as a standard device or a reference device. So, by comparing my device with this performance of the standard device, I can tell if the reading is right or not. This is called as accuracy. How good is my device? How reliable it is? How reliable the reading is? Consider this thermometer. You have the span from 0 till 50 degree. So the range of it is from 0 to 50. You can measure only temperatures that is from 0 till 50. You can't measure temperatures that are below 0 and you can't measure them that is beyond 50. So 0 to 50 degrees is the range of the device. At what range will you measure the temperature? If you have a furnace which is burning at 150 degrees Celsius, you won't be able to use this device to measure that furnace. So you need to know where you can use it. Say you are measuring human body's temperature using this thermometer. It has a range from 0 till 50 degree. So the human body's temperature will fall something in between this, right? So even if it is beyond 40 in extreme cases, you can still use this device. So when you are choosing a device, you should first check its range and what you are probably going to measure. So you have to check whether this range fits in your probable measuring temperatures range. That's the first thing that you will check. Next thing is the accuracy. How good is the device? So, like I said, say I measured a temperature, the red line is spotted here. I have 5 divisions between 30 and 40, so each corresponds to 2 degrees. 30, 32, 34, 36, 38 and 40. So, the temperature is 38 degrees Celsius. Okay, I forgot to mention the unit is Celsius. It measures temperature in the unit of Celsius. Okay, so the temperature is 38 degrees Celsius. I will measure this against a standard device and then compare whether my reading is right or not. If the standard device says the temperature is 37 degrees Celsius in the standard device, so can I conclude that this device is faulty? No, I should not. There is something else that I should consider. This standard device measures 37 degrees Celsius. Is it possible for you to measure 37 in this case? You have 5 divisions between 30 and 40 and each corresponds to 2 degrees Celsius. So, you can measure minimum of 2 degrees Celsius using this device. So 2 degrees Celsius is the resolution of this device. What is the smallest amount of temperature that you can measure using this? That is called as resolution. You can remember it like this. Your screen resolution will be 1920 x 1080 or something close to this, which means the rectangular width is 1920 pixels, which means your monitor is divided into 1920 pixels, and that is the smallest amount of light that can be shown in that device. That is called as resolution. Same is the case for any device. Resolution is the least value that you can measure using this device. So, since the resolution is 2 degrees Celsius, you cannot accurately measure 37 degrees Celsius with this device. So, you should look for another device which measures 30 till 40 with 10 divisions, so that the resolution becomes 1 degree Celsius and you will be able to measure 37 degrees Celsius. Let us say, for example, your standard device reads 37.5 degrees Celsius and I am going to draw the portions between 30 to 40, leaving the other readings. So this is your thermometer that you are considering now. It has resolution of 1 degree Celsius. So you are comparing it with the standard temperature of 37.5 degrees Celsius. Here again, you will get the reading to be 37 or 38, but not in between. So this number of digits that a device can measure is called as precision. How precisely will it actually measure the temperature? That is precision. This device is capable of measuring in 1 degree steps. It will not be able to measure 0.5 degrees Celsius. That is called as precision. How precisely or how observant the device is. That is called as precision. Precision can be told as the number of significant figures that a device can measure. So, it can measure up to 1 degree Celsius, or it is precise up to 1 degrees. So, your standard device has a precision of measuring 1 decimal place. It has the possibility to measure this, but your device cannot do that. So, the precision is 2 digits. Precision can be measured by the number of significant digits that a device can measure. So, here it is 2 digits. But here it is 1 decimal point after a digit. Let's say, for example, your device is having divisions like this. Up to 1, it is 37.1, 37.2, 37.3 and etc. And you are asked to measure the temperature of a medium which is 37.008 degrees Celsius. So, the medium's actual temperature is 3 digits post the decimal point. So, you need a device which is capable of that. But say, for example, your device can measure from 37.1, 37.2, 37.3, etc. up to 38. If this is the number of divisions that you have in your device, you won't be able to measure this accurately. So, this quantity is called as precision. How observant your device is, that is precision. So, the precision will be 1 decimal digit. Is its precision. Here, what is the resolution of this device? It is not 2 degrees Celsius, it is 0.1 degree Celsius. That is the resolution of the device. Resolution and precision isn't the same. Resolution is the smallest amount of temperature that it is capable of measuring, and precision is the number of significant figures which will be shown in that display. Say, for example, it is still measuring this 37.008 degrees Celsius. It is still capable of measuring. The mercury levels will rise corresponding to this temperature. But you won't be able to accurately see if the device is not precise enough. So, resolution is different, precision is different. done an experiment in your class 10 and class 12 by using litmus paper. You would have tested the pH level of a solution. If the litmus paper turns blue, the medium is acidic. So, based on the color of litmus paper, you will be able to decide on the medium of the test case. Say for example, you are putting the litmus paper inside this liquid. You have a liquid here. You want to measure whether this is acidic or basic. So, you are inserting your litmus paper here. And it doesn't change colors. It is in the same thing. So, based on this, how will you tell whether the litmus paper displays the correct acidity of a medium or not? Say for example, this litmus paper is designed to turn blue when the pH is less than 7.45. So, this is the specified level for which it will turn blue. And let us say for example, my medium has a pH level of 8.54. Let us say for example, this is 8.54. So, the pH level is not met. So, the litmus paper will say that this is alkaline and this is not acidic. I am giving you another scenario. This is case 1 and the case 2 is I am taking another litmus paper which will measure the pH if it is just less than 7. Okay. So, let us say my pH level is 7.00001. So, this is the pH level of that medium. So, in that case, will the litmus paper turn blue? It will not turn blue. You can't decide whether it is slightly acidic or slightly basic be just based on this litmus paper. Whereas, this one has a better sensitivity. It detects pH if it is less than 7.45. If you choose brand A's pH or if you choose brand A's litmus paper, it would have turned blue for this solution because 7.00001 is less than 7.45. But here it has a sensitivity. I am going to tell you what a sensitivity is. Here pH level, when it is less than 7, only then this litmus paper will turn blue. So, there is a difference in sensitivity between these two litmus papers. In the first brand, it will turn blue when it is just less than 7.45. So, you need to pay attention to how sensitive a device is. How good is it in receiving output that is sent by your measured value so that it can give you a correct reading. When you want to measure the pH of different solutions which is between 7 and 7.1, say for example you have pH in the range of this 7.001, 7.0057. If you want to probably measure these pH levels, you should choose brand A's meter, brand A's litmus paper and not brand B's litmus paper. So, whenever you are choosing a device, you should pay attention to how sensitive the device is. Sensitivity is the change in the output divided by the change in the input. How quickly does the device indicate whether there is a change in the measured system or not? I'll give you another better example. Say you have a mobile phone and it has a mic inside the mobile phone, right? So, when you are making a call, there is a specified sensitivity of the mic that is there in your mobile phone. It will be picking up signals that is greater than certain decibels value. If your noise signal or if your voice is less than that decibels, it will not receive yours. So, that amount of sound which it can detect is called as sensitivity. If the diaphragm of your mic is so thick that it doesn't move when you are speaking, then it probably isn't sensitive enough for you to use. Say for example, even if there is a small air noise like this, you will be able to hear this, right? So this means my mic is capable of detecting even that very little noise that is there. So that is the difference that is called as sensitivity. When you are choosing a device, you should probably think what it is going to capture. If it is capable enough to capture the signal that you are going to send. If you are planning to use a mic, you have to decide whether it has to be noise cancelling or noise accepting. If you want a noise accepting mic, you should go for most sensitive mic that is available, so that even if there is a small fly that is crossing it, it should be able to capture the sound of the fly, and it should also be able to capture your voice. Say for example, you don't want to watch all the drama that's going behind you. Say for example, you want to buy a mic for your YouTube channel. You are going to just speak and you don't want the background noise to interrupt in your video. So in that case, you will adjust the sensitivity of your mic such that it will be able to collect only your noise. So that is called as sensitivity. Consider this case. We are going to talk about other few cases which are not really desirable for a measurement system. All these things, range, resolution, accuracy, sensitivity, all these are desirable characteristics, meaning that you will want your system to be more accurate. You will want your measuring device to be more precise. You will want your device to be as sensitive as possible. So, all these are desirable characteristics. We are going to talk about few other characteristics which are not really desirable. Consider this case. The actual temperature keeps on increasing and your device is also expected to increase its reading based on the actual temperature. But when I am keeping on increasing the temperature from 0 till say 10 degrees Celsius, I have a ice, okay, I have a medium at 0 degrees Celsius. I am just keeping on increasing the temperature. But your device responds only at 10 degrees Celsius. Your meter says it to be 10 degrees Celsius only when it is 10, and from 0 to 10 there is no response. And here on, when you are continuously increasing the temperature, it is keeping on increasing the temperature. And let's say at 50 degrees Celsius, you are reducing the temperature of that. So at that case, it will also fall back in the same path. This gap from 0 till 10 degrees Celsius is called as dead zone. The dead zone is from 0 till 10 degrees Celsius. Ideally, there should be no gap. Your meter is expected to respond as quickly as it receives signals. So, ideally, the dead zone should be 0, or your meter should be able to respond at all levels of temperature or at all levels of the measuring. This dead zone is not a desirable characteristic. We will talk about another concept called drift. Consider this scenario where your temperature is increased from, let us say, 25 degrees Celsius, and it is increased continuously in this range. Okay. This red line is your meter's reading. When the actual temperature is 25 degrees Celsius, your meter is actually showing only 10 degrees Celsius. And as the temperature continues to increase, there is an increase in your meter's reading as well, but it is not up to the true value. You need to add something to it in order to get the true value. This is called as drift. So, this is the drift that your device is having, meaning that you need to add something to the reading in order to get the actual reading. These two things, the drift and the dead zone, isn't a desirable characteristic. Consider this scenario. Here, your device is both slow as well as it isn't up to your actual value. So, it also has a dead zone, it also has a drift. This is a totally undesirable characteristic. If you get a characteristic like this, then it means your device has a dead zone issue plus a drift issue. So these are the two parameters that are undesirable. I'll give you a quick recap of what we discussed now. We first saw accuracy, how good your device is. Accuracy is the difference between the true value and the actual value. How good your device is. That is called as accuracy. The next parameter that we saw is precision. Precision means how accurately or how precisely, how exactly your device will be able to measure the actual value. That is called as precision. Next, we saw a device sensitivity. How accurately it will be able to capture the input that is sent to it and present in its readout. That is called as sensitivity. Then we saw another parameter called resolution, which is the smallest amount of input that this device will be capable of displaying. That is called as resolution. Next, we saw two other characteristics. One is drift and deadband or dead zone. Dead zone or deadband is the range of inputs for which the device will be dead, or it will not be showing any result for those inputs. Next, we saw drift, which is the steady decline in the measured value when the true value is different. The decline is steady and your meter is also functioning. This condition is called as drift. Now, let's discuss about few more things, which is repeatability and reproducibility. Both are similar. It is easier to get confused between both these parameters, but you have to pay attention to it in order to understand whether it is repeatable or whether it is reproducible. Let's say, for example, I am doing an experiment. I am doing it under certain conditions. I am using certain apparatus to do that experiment, and I am measuring the results using certain meters. So, under these conditions, I am doing the same thing tomorrow. The experiment should give me the same result as I got it today. Let's say, for example, I am measuring the acceleration of gravity using a simple pendulum. Today I do the experiment, I calculate the number of oscillations, and then I found out the acceleration due to gravity today. Tomorrow, if I do the same experiment, I should get the same reading, which I obviously will not get, and for different reasons, we don't get the same reading every time that we do. It depends on many other factors: the air's condition and the other ambient condition, temperature of the room, the weight of the bob. All these things depends on the acceleration due to gravity that we are actually finding it out. So, okay, let's say for example, under exact same conditions, I'm going to try it again. I'm going to repeat the experiment. Even if I repeat, I should get the same value of acceleration due to gravity. I should get the same results. If I'm getting it, then it is called as repeatability. If the experiment procedure is said to be repeatable, or if you use a certain device to measure something today and you are repeating the same thing, it should also give you the same result in your next trial. So in repeatability, all the conditions are same, only the next trial or the number of trials differs. Let us talk about reproducibility. When I say that a device is reproducible, it means I am following certain conditions to do an experiment and find out certain values. Say for example, my friend does the same. My friend is doing the same experiments under the same conditions using the same apparatus. He should also get the same results. Then that experimental procedure is called as reproducible procedure. The reproducibility and repeatability should ideally be same if both experimenters are equally good. Say for example, my friend does a better job than me. He is more keen in observing the results. He avoids parallax errors. He observes things accurately. He uses the right set of apparatus to do it. Or even if he is using the same set of apparatus, he is more observant and he got another reading. So if he is like that, the reproducibility factor will be affected, because I will do the same experiment 1000 times and still if I say the acceleration due to gravity is 9.25, He does the same experiment again, but he gets the acceleration due to gravity as 9.62. Okay, so the reproducibility factor and the repeatability factor should be same. If it is not same, then it means there are gross errors or there are human errors in that experiment. So we saw another two characteristics now, which is repeatability and reproducibility. We learned few concepts today. In order to test whether we really understood it or not, we have to experiment them. We need to solve some problems and test the concepts that we learned. Okay, so in my next video, I'm just going to solve some problems based on all the parameters that we solved today. You can pause the video, try it out by yourself, and then check the accuracy of your answers. Okay, so thanks for watching. If you like this video, give a thumbs up and subscribe to my channel for more updates. Don't forget to ring the notification bell as well, because only then you will be able to get a notification on your mobile phone when I'm going to release my next video on problems of static characteristics. Thank you.